Welcome to Shifting Grades YouTube channel. We are going to check on mathematics on our topic of trigonometric ratios, and we'll start with the three trigonometric ratios, which are the sine of theta, and the next one is cosine of theta. The third one is tangent of theta. We can use some mnemonic to remember them in an easy way, which is SOHCAHTOA. And we take it into three parts. The first one will be S, sine of theta equal to opposite of a hypotenuse. The second one will be representing the cosine of theta, which is equals to adjacent, F for adjacent, over the hypotenuse. And the third one will be the tangent of theta, which is the opposite over adjacent. These trigonometric ratios apply only in right-angled triangles, whereby, let's have a sketch. A sketch of a right-angled triangle. And let's have our theta here. This is 90 degrees. And this other angle will be, let's call it alpha. Let's name our sides X, Y, and Z. Now the sine of theta, using the given values here, will be the opposite of this angle theta, which is our X, over the hypotenuse, which is Z. The cosine of theta will be the adjacent of this theta, whereby adjacent means next to, so it is Y over hypotenuse, whereby our hypotenuse is Z. And the tan of theta will be equal to opposite of this theta angle, which is X, over the adjacent, which is Y. Let's say, for instance, we have a question whereby we have been given the sine to be a given value, and then you are required to find the other trigonometric values. For example, find the tan of theta given the sine of theta is equals to 3 over 5. Let's have solution here. First of all, we have to sketch a right-angled triangle so that we can identify our adjacent, our opposite, and our hypotenuse. So let's sketch the right-angled triangle there. We can choose any angle other than the 90 degrees to be our theta. Let's choose that one. And then, using this one, sine of theta equal to 3 over 5. We already know that sine of theta is equals to opposite over hypotenuse. So the opposite of this theta will be equivalent to 3, and the hypotenuse will be equivalent to 5. We have one unknown side, and we can use the Pythagoras theorem to find the remaining side, whereby the square of the two short sides is equals to the square of the longer side. So we can let this unknown side to be, we can call it A. So we'll have 3 squared plus A squared equals to 5 squared. We can group the like terms together. A squared will be equal to 5 squared is 25. When we take this to the other side, it becomes a minus, and 3 squared is 9. So our A squared is 16. Square root both sides, you get A equals to 4. So our A is 4. After we get this side, we can be able to get the remaining trigonometric ratios, which are the tan, and also we can also get the cosine of our theta. So back to our question, the tan of theta will be equal to the, you already know that SOHCAHTOA, TOA for the tan of theta equal to opposites over adjacent. So the tan of our theta will be the opposite, whereby the opposite is 3 and the adjacent is 4. And that is it. You can decide to put it into decimals or you leave it at that point. Next, let's check on trigonometric ratios of special angles. Which are these special angles? They are, you can say 30 degrees, 45 degrees, and 60 degrees. And then we're required to find the trigonometric ratios of these angles without using a mathematical table. Let's consider 2 triangles in this case. We can start with an equilateral triangle. Equilateral triangle means both sides are equal, and also that implies both angles will be equal. So you can have an equilateral triangle and of length of 2 units, 2 units, 2 units, 2 units. Then the angles here, since the angles of a triangle add up to 180 degrees, it means each angle here will be equal to 60 degrees, 60 degrees, 60 degrees. Let's name the sides of this triangle A, B, C. Then we can bisect this triangle from angle A to line BC into 2 halves, and then we consider just one part of the triangle. And we can name this middle side to be D. So we can have the remaining half of our triangle, which is A, B, and D. Remember, this was 2 units. This was 60 degrees, but then we have divided this into 2, so it will be 30 degrees. And here, this BC has been divided into 2, so we remain with 1 unit. And since it was bisected here, it is 90 degrees, is that 90 degrees. Now, we can get side AD using Pythagoras theorem too. Let's name it y, and we use Pythagoras relationship to get our y. We have 1 squared plus y squared will be equal to 2 squared. So y squared equals to 2 squared is 4. When this one comes to this right hand side, we negate it to be a negative. 1 squared is 1. So our y squared will be equal to 3. That means our y, when we square root both sides, will be square root of 3. And now we have our side y as square root of 3. From here we can get all the trigonometric ratios of angle 60 degrees and angle 30 degrees. Let's start with the ones for 30 degrees. From SOHCAHTOA, you can have sine of 30 degrees. This is our 30. Is equals to opposite. The opposite of 30 is this line, which is 1 over the hypotenuse. You can go to cosine of 30 degrees. It will be the adjacent of this 30 degrees, and the adjacent is just this line next to our angle, which is square root of 3 over the hypotenuse, which is 2. And the last trigonometric ratio for our angle 30 is tan of 30 degrees, and it is the opposite of 30, which is 1 over the adjacent, which is square of 3. Next to our angle 60 degrees, sine of 60 degrees will be equal to, come to your triangle here. Here we have our 60 degrees and sine is opposite. This is the opposite of 60, which is square of 3 over the hypotenuse. Hypotenuse is usually the longest line in a right-angled triangle, which is 2. Come to the next trigonometric ratio, cosine of 60 degrees. And cosine is adjacent, and the adjacent of 60 is 1 over the hypotenuse, which is 2. And the last one is tangent of 60 degrees, which will be the opposite. There is the square of 3 over the adjacent, which is 1, and we can just leave it as square of 3. Those are the trigonometric ratios of angles 30 degrees and angle 60 degrees. The remaining special angle is 45 degrees. And for this 45 degrees, we consider an isosceles triangle. Isosceles right-angled triangle. Right-angled triangle. Isosceles means two sides are equal, and it is also a right-angled triangle. So you can have a sketch of the same. A sketch here. This is where we have our right-angled 90 degrees, that is. We can have the two equal sides to be 1 unit, length of 1 unit, length of 1 unit. Sum total of angles in a in a triangle, they add up to 180, that is 180 degrees. So the remaining angles will be 45 degrees and 45 degrees. Remember, isosceles triangle has the base angles equal to each other, they are equivalent. The same way we have the sides equivalent to each other. Now, let's get the length of this unknown side, and our unknown side is the hypotenuse. We can name it B, and we use the Pythagoras relationship to find our side B. As long as a triangle is right-angled, you can use the Pythagoras theorem. So we'll have 1 squared plus 1 squared equals to B squared. 1 squared is 1 plus 1 equals to B squared. So this is 2 equals to B squared. And since we want B only, we square root both sides. So B will be equal to square root of 2. Our B now is square root of 2. We want the trigonometric ratios of angle 45 degrees, and we can use either of these. They are all equal. So from SOHCAHTOA, we can start the sine of 45 degrees. Let's consider this one. You can consider any since they are both equal. So sine is opposite. Opposite of this is 1 over hypotenuse, which is square of 2. Cosine of 45 degrees is the adjacent of this is 1 over hypotenuse, which is the square of 2. And finally, we have the tan of 45 degrees, which is opposite. The opposite of this 45 is here, 1 over the adjacent, which is 1. 1 over 1 is same as, is equivalent to 1. Thank you for listening. You are welcome to like, share, view, and subscribe to Shifting Grades, the only YouTube channel which is educational to your kids. Thank you.